For this example here, we want to make sure we factor the numerator and denominator, and we want to try to see if we can simplify the fractions first. And that's a general rule, we should try to simplify fractions first. So if I factor this out, I end up with 5x, x plus 2, and in the denominator I end up with x minus 3, x plus 2, minus x minus 2, and here we end up with x minus 3, x minus 3. Okay, so just starting off with our domain, because before we do anything, we really should state our domain restrictions. X cannot equal to positive 3, negative 2. Now, once I've done that, I want you to recognize that we can simplify this fraction first. Now, if we don't simplify this fraction, it still works. We end up with a common denominator that was going to be x plus 2, x minus 3, x minus 3. But if we do that, we're going to end up with a higher degree term. So a polynomial will have higher powers on it than we would need, which is not advantageous. We want to try to keep the powers down low, because the lower the power of the polynomials, the easier they are to work with. So I'm going to first of all simplify this fraction, and I'm going to make a note here. So we want to simplify rational expressions, and fractions as well. Rational expressions first before you add and subtract. Okay? Because it is much easier to add and subtract with lower powers and smaller looking expressions than it is to deal with higher power expressions. So I'm just going to rewrite this here. So I end up with 5x, x minus 3, minus x minus 2 over x minus 3, x minus 3. So if I were to multiply this by x minus 3 and x minus 3, I'd end up with a third degree polynomial here if I didn't cancel these out. But since I've canceled them out, I'm now only going to deal with the quadratic. Okay, and here I would have multiplied top and bottom by x plus 2. Now I don't need to do anything because that already has the lowest common denominator. So we should try to simplify fractions first, cancel out common factors first, before we add and subtract. So at this point we end up with 5x squared minus 15x minus x minus 2, so plus 2. That's all over the common denominator of x minus 3, x minus 3. Combine like terms and we're done. So minus 16x plus 2, that's not factorable. And that's all over the common denominator. Okay? So if we can, we should try to simplify fractions first before we add and subtract. It just makes it much easier to deal with if we do that. For this one here, now we have to be a little bit careful, because first of all, let's start with the restrictions here. Okay, so we cannot let x equal to 3. But because of the square root, we have an inside domain restriction, and x cannot be less than or equal to 3. Okay, so putting those together, we end up with x is not equal to or less than 3. Or we can say the reverse, x must be greater than 3. Okay, so x is greater than 3, we're not dividing by 0, and we have positives in the square root. Okay, so there's our restriction to start. So we're going back to our radicals unit to state this restriction here. Okay, so now we have to figure out the factors. Okay, so this can be factored. Since we have a square root, we can involve the square root as a factor. This can be factored into square root of x minus 3 squared. Okay, so maybe do that in a different color here. So I can make this the square root and square it. Okay, that means that I have a factor of x square root x minus 3 times square root x minus 3. Each of those square roots represent a factor now. I can express square roots as times pieces. So what I end up doing here then is I have an x minus 3 square root minus square root x minus 3 times square root x minus 3. My common denominator I get by multiplying by square root x minus 3. So there I now have a common denominator, and I can now add those fractions together. So I end up with x root x minus 3 minus 1. There are no like terms here, so don't try to add it together. And I'm just going to express my denominator as just x minus 3. So there it is. Okay, now I do have restrictions because I can't divide by 0, but I also can't have negatives in my square root.